Hello everyone, in this video I'm going to speak about the possible mechanisms for chemical reactions. Let's get started. First of all, and before speaking about the mechanisms, let's agree about some points. Reactions might occur all at once, so we have one-way reaction that start from reactants and produce the final products directly in one single reaction, or we could have several discrete steps for producing the desired products. In a multiple step process, one of the steps will be slower than the others. A reaction mechanism consists of a series of steps that make up a more complex reaction. Each simple step involves a maximum of two molecules colliding. The slowest step is called rate determining step, RDS, and the overall reaction cannot occur faster than the slowest step. So we have 4 points that we have to agree about before starting speaking about the reaction mechanism, which are the reaction could happen directly in one step, or it could go through several steps. These several steps will have different rates. The slowest step is called the rate determining step, and on each step we have a maximum of 2 molecules colliding with each other. We have also what's called intermediates and transition states. What's the difference between them? Intermediates exist for a finite time. What does it mean by existing by a finite time? They are stable. Intermediates are stable, so they could be considered as a product, okay? And we can use this product again in some other steps to produce other products, okay? So, but if we compared it with the transition states are not stable. They will not exist as a product or not produced as a desired product. They have a high energy. They have high potential energy. For that reason, they just exist part way through every step of a reaction. We have here a simple example about the 4 points that we already agreed about for any chemical reaction. We have here wheat, okay? Let's call it W, okay? It should produce bread, okay? Let's call this bread D. Okay, of course, any one of you will tell me, okay, this is not a single step reaction or a single step process. Okay, what is the possible mechanism for making this bread from wheat? There must be some steps. Yes, correctly. So we can say that we start from W, we move to F, which is flour. We are making flour from wheat. Then from the flour, we are making we can say that we have 2 steps, okay? So from the flour, we can make bread. So we have here, let's say that this is step 1, and this is step 2. We started from wheat, which is the starting point, and we ended by the bread, which is the desired product. But when we wanted to make this bread from the wheat, we had to make the flour. And the flour here was a product from the first step, and it has been used, but it is still stable. What's meant by stable? It already exists. It exists everywhere. So it has like minimum potential energy. In this case, flour is considered to be intermediate. It is not a transition state because flour is stable, because flour is already a product that could exist. So it is a stable intermediate. And we started here from wheat, making this flour. This flour, which was produced, is is used in the second step. For that reason, this is a possible mechanism. Why this is considered to be a valid mechanism? Because by the end, what is our final equation? Wheat will make bread, which is matching with the process that we know or what we desire to make. We would like to make bread from wheat. So this is what has happened or what has been produced from the proposed mechanism. What about the flour? The flour that has been produced has been used in the second step. Now let's go ahead start speaking about the chemical reaction. We have here a reaction which is representing A plus 2B is giving C. A plus 2B is giving C. And we would like to give or propose a mechanism for this reaction. Let's suppose that this is not a single step reaction and we have like 2 steps for this reaction. Scenario number 1, we could say that B plus B is giving Q as step 1, and we have enough experimental data to tell us that this is rate determining step. How did I say that this is rate determining step? I cannot predict which one is the rate determining step. I can know that only from 2 things, either from experimental data or an experiment, or from the rate equation, as I will explain now. This step 2, which is the fast step. Why is the fast step? If we have one step which is slow, the other steps or the other step will be fast. So we have here B plus B is giving Q, Q plus A is giving C. How did I suppose or propose these two steps? This is simply because if you try to cancel out the intermediate, you will have an equation which is matching with this main equation. The proposed steps or the proposed mechanism is already giving an overall equation which agrees with the main equation. Step 1, again, step 1 is the rate determining step. Again, I cannot predict the rate determining step. I should be given data to tell me that this is the rate determining step. Why? Because I will use this rate determining step to write my rate expression. If step 2 is the fast step, so the rate step 1 will be the slow step and the rate determining steps. Why I should care about identifying the rate determining step or the slow step? Because its reactance. So if this is the slow step, its reactance will be represented in the rate equation. So the rate will be equal to K multiplied by the concentration of B square. We can understand from that you can write the rate equation from the rate determining step. One of you will tell me, how can we write a rate expression? Didn't we agree before that the rate determining step, the rate equation or the rate expression can only be determined from experimental data? Yes, that's correct. But also, I said now that the rate determining step will not be predicted. It is given or it is determined according to experimental data. So we will know the rate determining step from experimental data. So as long as we know the rate determining step from experimental data, we can use its reactance concentration to write our rate expression. This is scenario number 1. What about scenario number 2? In scenario number 2, we can say that B plus B, we have already given data to tell us that this is the fast step. Let's assume that we have data telling us that the second equation is considered to be the rate determining step. For that reason, the rate equation or the rate expression or the rate law will be written as Q multiplied by the concentration. The rate is equal to K multiplied by the concentration of Q multiplied by the concentration of A. So you can just observe that we cared here in scenario number 2, we cared a lot about step 2. Why? Because it is the rate determining step. But in scenario number 1, we cared a lot about step number 1. Why? Because step number 1 is considered to be the rate determining step. One more thing that we have to care about here, which is Q. Q is not in the main equation. How can we include something which is not in the main equation? No, we cannot do that. So we have to substitute or replace Q with something from the main equation. We already can see that Q is coming from 2 molecules of B, so we can replace it with B squared. Again, we cannot have Q in the rate expression. Why we can't have Q in the rate expression? Because Q is an intermediate, and we cannot have intermediate in the rate expression or the rate equation. For that reason, we have to search, check our steps. Where is Q coming from? Q is coming from two molecules of B. The rate equation, again, very important. The rate equation contains concentrations of what? Of reactants. For which step? For the rate determining step. So our main concern, if we have different steps, like scenario number 1, scenario number 2, we should care about the rate determining step. Which one is considered to be the rate determining step? Is the first step, second step, third step? According to the problem or according to the question, we will be able to use the concentration of the rate determining step reactants to write our rate expression. Hope it's clear. See you later.